This assessment asks us to analyze the results of an isotopic labeling experiment that shows that if you label O18 in the carbonyl, that O18 label, half of it, ends up in water. And what does that mean for the mechanism of this reaction? Well, one thing it means is the carbonyl oxygen becomes the oxygen in water, at least some of the time. Now, I don't want to go through the entire mechanism here, but one of the intermediates that we're going to get in this reaction will eventually be this, where we have two oxygens in the molecule. These were the two oxygens that were originally a part of the carboxylic acid, and the isopropyl group will have been added. This intermediate, again, this oxygen, let's say that this is our O18 label, what was formerly the carbonyl oxygen. From this intermediate, we're going to protonate and have that molecule leave. That's what's going to allow the O18 to end up in water. So the first part of that experiment is the carbonyl oxygen becomes water. But why does it only become water half of the time, or in 50%? Well, that's because there's this hydroxyl group here. How do we know which one we should protonate? Neither is going to be protonated favorably, which means we're going to protonate both. So half the time we'll protonate this hydroxyl group, which was the OH of the carboxylic acid in this hypothetical experiment. Half the time we'll protonate this one, which was the carbonyl oxygen in this hypothetical experiment. And so these will leave 50% of the time each. That's why only half of the O18 label is in the water, or water is labeled with O18 only half of the time.